Students, I welcome you all for the series of lecture for the software visual components for the course Factory Simulation Laboratory. So as of now, we are in the series of lecture within which we are in the fourth lecture where we are going to get into the actual exercise. So far what we discussed was the significance of factory simulation we discussed. Then the second lecture we learned about the graphical user interface of the visual components software. To be precise, the e-catalog facility and the PNP mechanism, that is plug and play mechanism we discussed. Then the third one was with respect to the demonstration of the software, how to toggle between the menus, how to go ahead with the layout we discussed. And of course, in the end of the third lecture, we learned about saving of the file, and the file extension for visual components was .vcmx. So this was the discussions what we had in the previous lectures. And today, in this particular lecture, we are going to get into the actual cycle. So as per regulation 22 curriculum, you are aware of the fact that for a course, we have got a laboratory course, we have got 12 experiments where they have been divided into two cycles. Of course, two cycles, each cycle carries 6 exercises. So in the first cycle, we are going to get into the first exercise. We knew the fact the first exercise is going to be the basic thing where you are going to get introduced into the software, and then based on the progress of the exercises you get into multiple options, and therefore the comprehensive nature of the exercises will be getting a little bit, it will be getting deeper, so that the act of learning as well the contemplation of the software too increases with respect to the progress of the exercise. So the first exercise is modeling and simulation of workstation with human interface. So here we are going to model it, we are going to simulate it. And of course, the deliverables is going to be just the drawing. Of course, there might be a question how to get statistics and other things. So as the learning guide, the starting itself, it will be a little bit difficult when you get into statistics. Therefore, in the advanced part, we'll have the statistics. So right now, we will focus on the configuration. So the first exercise is, the title is modeling and simulation of workstations with human interface. So here, the basic idea here is you are going to get introduced into the various aspects of factory simulation, of course, in the beginning stage. So the initial act will be of modeling the workstations. You are going to have a human to do all the things. You are going to simulate and you are going to get the results. The deliverables, the outcome of the exercise will be a mere drawing in the initial stage. Of course, lot of statistics, the data, quantitative data is also involved, but that will be dealt in the later case, maybe in cycle 2. In cycle 1, you are going to be introduced into the various aspects. So let us learn still more deeper in this regard. So the main objective here, it is going to be to simulate a manufacturing workstation where human operator, to be precise, not plural, operator will interact with the machines, robots and material flow using visual components. How do you do? On a very simpler case. Now, let us understand the block diagram first, because that paves you a very good understanding. So how to go ahead, how to kickstart with the process. So when you get into the block diagram, the first basic case is we are having a conveyor belt or a trolley at first point. On the left side, we are going to have a conveyor belt. So conveyor belt, you guys knew that it's just a depiction of a conveyor belt where the product is going to move from one end to the another end. Now we have got another conveyor belt within which where there is a gap. So the product which travels on trolley 1 should come to trolley 2. That is from conveyor belt 1 to conveyor belt 2 with the predetermined gap in between. So that is where a human is going to come. Now let us understand how to take care of that migration part from a design perspective. So we are having two parts at the end of the trolley. That is the flow is going to be from the trolley one from left to right. At the source point, the product is going to stop. Then on the second right side part, we are having a conveyor where that acts as a destination, and the product on the source will come and stop. Now somebody, a human, that somebody is nothing but a human, should pick this part from the source and they are supposed to keep it on the destination. So we are going to have a human. Now, let us understand the software. Whenever you go for a human, in a software perspective, they are considered to be resources. Whenever we go for a resource, then obviously we are supposed to have a crucial element called as controller. We are supposed to have a controller because controller is the one which is going to give instructions for the human. It might be a robot, obviously robot control comes into picture. When you have an AMR, when we have an AMR, autonomous mobile robot, we need to have a controller. So wherever the resources comes into picture, obviously we are supposed to have a controller without which the product will not work. Now the main part is controller connection, therefore that gives the instruction. So now let us get into the exercise directly. So this is how we have the screen where we are going to start the kickstart with the activity. So the first case is, let us save the file. So on the top left corner, we knew the file option, go to save, have a location, save the file under the required name. Now the file has been saved. On the top, you can see the file name also. Now let us search and get the thing. So on the all models option on the e-catalog, we just type it as conveyors. So now there are two options are there. You can directly pick and place. So left click and pick it, hold it and then drag it. You can get it. So that is going to be. Or the other option is you can just double click it. A left double click will solve the purpose. You get the component. So now we are fitting it to the screen. So you can observe, a crucial observation is necessary here. The thing is, there are arrowheads are there. The arrowheads is pointing towards. That means that the trolley or the conveyor is going to flow the component on that particular direction. That is, in this particular case, it is going to flow from left to right. The direction is very, very crucial. When you have the direction, then obviously the component is going to move in that particular direction only. So you are supposed to be very cautious enough in deciding the direction. Now the next thing is, let us get into the mouse button option. So that is again quite crucial in this regard. So obviously we knew the fact there are four functions. There are four functions available in a mouse, optical mouse. The first is left click. So here left click, it is going to select the component. It is only for the selection of component. Then right click will rotate the part. On the GUI, right click will enable you to rotate the part. Just hold it and then move the way however you want. Then the scroll wheel. When you press the scroll wheel, it is going to act as a pan. It is going to act as a pan. Whereas when you scroll down the wheel, when you rotate the wheel, obviously zoom in and zoom out is going to occur. So these all are the functions of a optical mouse in visual components. Now the next thing is a feeder. We need to have a feeder. So let us select the feeder. So we are selecting the feeder, the same process, double click it. Now, how to connect the feeder to the conveyor? This is another interesting part. So it's a plug and play mechanism. So you selected the component, keep somewhere else. Now, when you hover, when you take the feeder towards the conveyor, you can see a green arrow mark. A green arrow mark comes into it. So obviously it is going to attach together. So they are going to attach together. So that means that it has made a contact, it has got attached with that particular component, so they make a flow, they make the sequence ready. So you need to be very cautious enough, need to see that green arrow mark. Now we will simulate it. So you can see upon simulation, the product comes from the feeder, it goes towards the conveyor from left to right because the arrowhead was so. So now we'll see the further parts. So now we are in the top view. We can see the same. So whichever the angle you want, you can toggle it upon. Now we'll duplicate it. So we'll just clone it up. That is copy paste. Now we wanted to have a significant gap. There are two conveyors are there. Conveyor number one, which has been attached with the feeder. Conveyor number two, we wanted to have a predetermined space. So on the top view, we will just go ahead with. Now, when you want to have some sort of angular orientation, rather than being inline, when you wanted to have any angular orientation, the circle which starts at the initial point, you are free to rotate it by the required angle. So on the right side, you can see there is an angle, or is it where even you can quantify it. So that's how we give the angle. Even we can make angular orientations also. It is possible. It does not mean that always it is supposed to be inline. Even angle orientation is also possible in visual components. So now we'll fit it up. We'll fill the screen. We'll go for the next component. Now when you simulate, what happens is the product flows from the feeder. It comes to the conveyor one and it gets stopped. It is not coming for that. It is getting disappeared. It is not coming for the second thing. That's where we are going to focus upon. So from that source to the destination, it is supposed to come. Now we wanted to have a human to do it. Before that, the from point and to point has to be specified. So we'll go for from process conveyor, a node by name from process conveyor. So double click it up. You get it on the screen. Move to the requisite area. That is at the end of the conveyor. You can see the green arrowhead will pop up. And we'll take the to process conveyor. That node also will take. So now we are taking up two nodes. The first is from process conveyor and the second is to process conveyor. So from we are going to keep at the source point, to we are going to keep at the destination point. So we have chosen it. Again, double click it up. Now it is as easy. By holding the left click, we can move to the required position. Hold it and move to the requisite position of the conveyor table. So now we'll position it off. So 2 we are taking to its position, and from process conveyor also we are taking to its position. So you can fine tune it little bit, even you can move it wherever the way you want. So don't worry about that cyan color arrow mark which shows in the opposite direction. That has a different unique purpose that we will see in the advanced cases. So wherever you want you can position, but not outside the conveyor. It should be on the conveyor, maybe precisely at the end of the conveyor. So automatically it gets plug and play. So it becomes easy for us to position it. You can see the green arrowhead and now it has been positioned promptly. So now when you simulate it, what will happen? It will come to that from process conveyor and it will get stopped. Earlier it was disappearing, but now it will not disappear, it will stop. Now we'll go for the further things. So now we wanted a human to do this particular task. So we have got two options, Hannah, a female, and a male by name Otto. So Otto, we brought him. So keep it approximately in between and ensure that the orientation is proper. The orientation is proper, that he faces towards the workstation. Else you need to rotate and you need to make an unnecessary movement, which will be a loss of time. So position him approximately to the source point so that he can pick it directly and he can place it onto the destination part. So after doing the position, let us go for a proper view. So this is the view which suits the best. And now we can see the cell graph. It is nothing but a model tree. What are the products we brought into the graphical user interface? It is in the hierarchy, the same hierarchy it has established, the way how we brought. So as told earlier, whenever you bring a resource, a controller is essential. So since here it is a human, so we need to have a human transport controller and pick it up and place it on the GUI. So you need not to be here near the operator. Somewhere you can position somewhere near to him because it do not has any sort of connections. So select the controller, go to the interfaces option, the home tab itself, we have got an interfaces option. The moment you click it up, you can see a certain set of dialog box pops up. Select the human and connect him to the resources on the controller. First, go to interface, select the human, then select the radio button of the resources. It gets linked up. So with that, the activity is done. Yes, now the thing is connected. Before simulation, there is another activity. That is, there are three entities are there. Entity number one, the from point, that is from process conveyor. The second entity is to process conveyor. It has to be connected by the human. Human is supposed to do this particular task. So what we'll do is, we'll go for the process. The moment you go to the process, under the process editor tab, so you can see there are certain labels being displayed. So first we'll go for the process. We saw the certain labels. Now we'll go for the flow. The moment when we click the flow on the output tab, that is the bottom of the screen, you can see there is a tab by name process flow editor. So now these three independent entities are going to be connected right now. That's what we are going to do right now. So this is how we have got one flow group. We need to define these parameters. So upon the definition, the task is done. The flow steps. So now we'll see how to do it. Now, when you come for the process node on the conveyor number one, you can see a label being popped up. So pick that label first. Then that's the from point. The moment you click, you can see it is being selected on the flow editor also. Then who is going to do the task? The controller, the human. So go to the controller, pick the point on the middle. Then come back to the to process, just the label. So have a keen observation. We are not kicking the nodes. We are not selecting the nodes. Rather, the label of the from process, then to the controller, then to the to process. Now it is getting connected. You can see the flow group has been established. So now we will simulate the task. The link has been established. We'll simulate. So now the product comes from the feeder. It comes to the source. The human comes to the proper orientation. He picks the pot. It goes to the to process and he positions the workpiece. And from then the workpiece goes on. So this is how the visual components does. So this is what the first exercise is all about. The speed is little bit slow, where we can go ahead with the increase in the speed of the simulation. Now the product is continuously coming, so we need to adjust, we need to synchronize the process, so we need to adjust the time. So select the feeder. On the right side you can see the properties under which product creator and interval. There is a 5 seconds interval. Let us increase the interval time. Upon increase, go to reset, go with the simulation, run the simulation again. So now the product comes. So the worker, that is auto, comes to his position, lifts the part from process. He goes to the second conveyor, places in the position, and then the product goes on. So this is the easiest way of simply simulating the workstation. Now the second part comes into the first conveyor, that is to the from process. Again the person, the human interface, he goes to the position, picks the part, comes back to the to process, and then positions it. So this is how the process goes on. So it goes on in the same thing. So when the simulation is running, you are free to toggle the camera angle wherever you want. Upon holding the right click of the mouse, just hold it and position wherever you want. You can see everything visually. So 360 degrees, you are free to go ahead with the camera rotation. So this is how we get the process. So it is as simple where we get into the work. So now let us reset it to do the further activities. The further activity is nothing but preparation of the drawings. We can prepare the drawings. So now we'll see it step by step. Now, how to export that into a video? So go to the video option, then select start recording. Now the video records. Now you are supposed to go ahead with the file location and save the file, record it up. Yes, you get the recording. Record it, reset, record it. Now the simulation speed is little bit low, and moreover we are defining whenever we go for recording, it is going to record frame by frame. But don't worry, the video will be continuously smooth because of the decoding activities. But while recording, it will be little bit frame by frame, but the output will be quite unique. So you need not to worry about the quality of the video. But while recording, it will be frame by frame. So that's where the lag is, though we increase the simulation speed. So this is how the output. So when it was recording, it was frame by frame, but you can see the output do not come so. It is going to be quite unique thanks to the decoding facilities, the encoders. Now we'll go for the images. Reset it, just go for an image. It is something like a snapshot, something like a sniping tool what we have got. So that is how we get the output. So now we will get into the further the preparation of drawing. So this is the model what we have created. Now go to the drawing menu. So under which select the view which we wanted to have. So here I am selecting the front view. So it is going to, the drawing is going to get uploaded. We can adjust this scale. Now let me delete it and let me do it again. Before that, we'll upload a template. On the template tab. We'll select an A3 template. Now we'll bring the required view. So that will help us to adjust the scale of the model what we have developed so that that can be fit into the drawing sheet. So that's the purpose of template. So now we can see the model is the scale is too low. So now let us reframe the scale. So once the scale is reframed, it is going to get fit into the sheet. So still we'll go for the better scale so that we get it get fit into the drawing template properly so that we get a good quality output. So once everything is over, then comes an important part, the creation of bill of materials. On the top, we have got an option called as BOM create. The moment you create it, automatically it is going to list out the bill of materials. What all are the materials necessary for it along with the balloon. So you can see the product number on the drawing template as well as a tabular format being displayed onto it. So this is how we get the drawing activities. So now how to edit it? So on the bottom left corner, when you wanted to edit something, when a simulation is running, obviously it is not possible for us to go ahead with it is not possible for us to go ahead with editing. So whenever you wanted to do any editing on the title block, the simulation must be in a pause condition or in a reset condition. So now let me go back to the original thing. Now the simulation is running. Now let me switch it off. That is reset. Now come back to drawing. Now double click on the title block and you can see the options are now editable. When the simulation is running, it will not be in a position to edit. So now the title block, we will type it as factory simulation because the space is restricted. So we'll not have factory simulation lab like this. Instead, we'll just have factory simulation. Then on the below part, you can see there is one thing called as part number. So again, go double click it. So for the part number, please have your registration number 2127 00 100 2, of course, your number. So this is how you can go ahead with. Now, the next interesting thing is where do we give the title of this experiment? So again, on the top, you have got an option called as text. Place wherever you want. Now double click on the right side portion on the properties where you can go ahead with the annotation. Double click and you can type what you wanted to have on it. So it is as simple as that. So you can go ahead with annotation. You can change the font style, font color, all the things you can go ahead with annotation. Now let me type it as the exercise 1, modeling and simulation of workstation using human interface. And then click onto the screen so that it gets updated. So now you can pan it and move to the required position, wherever the position you wanted to have. So you can have it in a prompt way. And now once the drawing is ready, we can go and convert it into a PDF. So go to drawing. Now you can't see anything. So what to do is just again go back to it. So don't worry about it. There is one option called as full preview. So just it's a checker box. So go onto it and click the checker box, check it up so that you can see the full preview. Now select the sheet size what you wanted to have. Select the proper PDF converter, that is printer. So now you get the drawing, everything, and now you can go for print. So save the location. If you are directly connecting it to a printer, you can get a printout. Since for the sake of record, we wanted to have a soft copy, so we'll save it in the form of PDF. In the record location, you can see the PDF being saved there. So when it is opened in PDF, you can see as such it is there in the PDF format. So this is how we do the activities. So now we completed exercise 1 and the output we are obtaining it in the form of video recording, we get in the form of PDF drawing, and of course a bill of materials we get. So on the visual components we did. So to summarize the learning today, so today we did exercise 1 on visual components virtually. We designed everything, we modeled, we using PNP mechanism, we modeled everything, went ahead with different entities were connected by means of process flow editor. We defined the flow, then we simulated, we ensured the running, we did setting manipulation to go ahead with a synchronized speed, then exported the same activity into a video form, and finally we got it in the form of a PDF. So with this, we finish exercise 1. I hope you would have got a good idea in this regard. So feel free to contact me for any difficulties in the due course. So thank you once again. Thank you all.